Hi everyone, so in the last video we talked about definitions of lines and points and circles, and now we're going to talk about something else within circles that you may not know. So in circles we can measure the angle of a circle or the angle, or really any angle, in two different ways. We can measure in degrees, which is what we're used to. So if I say like, oh, I turned around 180 degrees, that means I went all the way around, or not all the way around, but went around from front to back. 180 degrees would be from here to there. So I make basically like I spin around. 360 degrees would be all the way around. So this is 180 degrees. This is 360 degrees would be all the way around. 90 degrees is only a quarter of the way around. So we should be familiar with degrees, but the other way we can measure angles is with radians. Now radians, instead of using that degree sign, radians is measured in the amounts of pi, and we're going to talk about this a little bit more in your class next year in SM3, but for right now, all you need to be able to do is convert between these two things. It's kind of like converting between feet and meters. So they're just measured in two different ways. We can still measure them and it gives us the same answer. It's just two different numbers, because if I measure something in feet, it gives me one answer, and if I measure it in meters, it gives me another answer. But it still is measuring the same exact thing. So in this self-check, what we're going to be talking about is how to convert between radians and degrees and radians. So there's two different equations that we need to use. The first one goes, if we're given something in radians and we want to convert it to degrees, we're going to use this top equation, where we take the number of radians, whatever it gives us in radians, and multiply it by 180 over pi. Now, we use 180 in pi because 180 degrees is the same amount as pi radians. And so when we convert between radians and degrees, we just want the radians part or the pi part on the bottom, because what will happen is it'll cancel out. And I can show you that in an example. Then the next equation that we're going to use, this one down here, is when we go from degrees to radians. So this time we're going to take the number of degrees that we get and we multiply it by pi over 180. Again, now this is the same thing. We just flip-flop the fraction from 180 over pi to pi over 180. This is because when we want to get rid of or convert the degrees to radians, the degree part of the fraction needs to be on the bottom, or the denominator. So let's just go through some examples. The first example is 210 degrees, and we want to convert that to radians. So I'm going to use the bottom equation, where it's the number of degrees times pi over 180. So the equation I'm going to write is 210 times pi over 180. And when I plug that in, basically what I'm going to do, you can plug the entire thing into a calculator, but pi is an irrational number, which gives you a never-ending decimal, right? It's going to give you something gross. Instead, what I'm going to do is I'm going to do 210 divided by 180 in my calculator, simplify that, and then I'll just attach a pi to the end of my answer. So if I do 210 divided by 180 in my calculator and convert it to a fraction, that's the same thing as saying 7 over 6. Now, that's not my answer because I still need to worry about the pi. So my real answer is 7 pi over 6. I could say 7/6 pi, like put the pi on the outside of the fraction, or I can put it on the top of the fraction. It doesn't matter. But this, and I would even write radians. So 7 pi 6 radians is the same thing as 210 degrees. Again, it's just two different ways to measure an angle. All right, so let's do that again. For the second example, we have negative 60 as our degree. When we want to convert that to radians, we're going to use the same equation. So we're going to say negative 60, and even though it's a negative number, we still just plug it in, times pi over 180. So once again, what I'm going to do is just do negative 60 over 180, simplify that, and then attach a pi to my answer. So if I do negative 60 divided by 180 in my calculator, convert it to a fraction, I get negative 1/3. So I can say negative 1 over 3, and then I have to attach a pi to it. I'm going to put that on top. So it'd be negative 1 pi over 3. That's my answer. Because the top, and that's in radians, sorry. because the top just has a 1, I can potentially cancel that 1 out, and I can just say it's negative pi thirds radians. But those both say the exact same thing, and it doesn't really matter. That 1 could stay there, or it could go. It doesn't matter, as because 1 times anything is itself. All right, so questions 3 and 4 are converting radians to degrees. And so let's go back up here and look at that equation. So to go from radians to degrees, that's my top equation. You would do the number of radians times 180 over pi. So I'm going to take this 2 pi ninths, which is in radians, and multiply it by 180 over pi. Now, based on the rules of multiplication, and when we multiply fractions, we're really multiplying the tops and tops and bottoms and bottoms. And so what happens is we would have 2 times pi times 180 on top, and on bottom we would have 9 pi. Now, this is where something cool happens. If I have something on top and something on bottom of a fraction and it's the same thing, I can cancel it out. So you actually have a pi on top and a pi on bottom of this fraction, so I'm going to cancel those pi's out, which makes my job easier because now that the pi's are gone, we can just plug this into a calculator. What I'm going to do is plug in 2 times 180 over 9 and see what I get. So 2 times 180 divided by 9 gives me 40. So my answer is 40 degrees. And that makes sense. Notice that when we convert to radians, our answer has pi's in it, which makes sense. Radians are measures of pi's, are measured in pi's. And then when we convert to degrees, the pi's disappear because now we're going to degrees, and degrees don't have any pi's. So let's do that one more time. We're going to convert negative 5 pi fourths to degrees. So I'm going to do the radians, which is negative 5 pi fourths, times 180 over pi. Once again, when we multiply, we're just doing tops, tops, bottoms, bottoms. So I would have negative 5 times pi times 180 over 4 times pi. Because I have a pi on the top and a pi on the bottom, those things cancel out. And now I'm just going to say negative 5 times 180 all divided by 4. When I plug that in to my calculator, I get negative 225, and that is measured in degrees, so I put the degree symbol there, and we get negative 225 degrees. And this is how we convert between degrees and radians and degrees.